Section 1, Polygons, Video 2. Another description we can use for polygons is we can say that they're regular, which is to say that all sides and all angles are equal, which can be pretty powerful if you want to know any measure of any individual interior angle or exterior angle or side length. If we know it's regular, we know what they all are. For interior angle sum, we're trying to figure out what is the sum of all of these angles here inside a polygon, which this is also review, but if we write the sum of all of the interior angles, the formula we have is 180 times n minus 2, which the reason it's that is because when we triangulate the polygon into triangles, we see that we have four triangles in our hexagon, which we always have n minus 2 triangles. And so since we know the sum of the interior angles of a triangle, we can just say 180 times 4 triangles, or we can do 6 minus 2. If we know it's a regular polygon, and we want to know what's just the measure of one interior angle, we can just take the sum, which is 180 times n minus 2, where n is the number of sides, and divide that by the number of sides, which is the same as the number of angles. So n equals number of sides, or the number of angles, either way. Exterior angle sum is kind of a trick question, because when we're thinking about exterior angles, remember we're thinking about these ones on the outside. And so if we add them all together, we actually see that the sum of the exterior angles for any polygon any polygon equals 360 no matter what, as long as it's a convex polygon. It doesn't matter if it's regular or irregular. But if we just wanted to know one of the angle measures of the exterior angles, for a regular polygon, because we know that they're all equal, we'd be able to find just that one, because we could say one exterior angle. You just take 360 divided by the number of sides, or the number of angles. Here we have a couple examples, all looking at the same figure. And for these, I just like to start with the figure and filling in as much as I can. So when I look at this figure, I see I have quite a few angle measures, exterior angle measures, but none of the interior angle measures are written in. So I initially think linear pairs are going to be really powerful for this. So when I look at this first, I see I have this line, and I know the angle measure of a line is 180. So since that's 70, this inside must be 110. I can do the same thing here. I have a line that's 60, so this must be 120, because I just did 180 minus 60. This one, the exterior is 65, so the interior must be 115. Here, this must be 180. I have 40, so this must be 140. And that last measure I don't know, because we don't know either. But I do see that's our first question. It asks for the angle of QXZ. So QXZ is that exterior angle. Well, since I know that the sum of exterior angles is 360, I'm simply going to add all of the other exterior angle measures I have, and then I can find that missing one. So I can do 70 plus 60 plus 65 plus 40 plus that missing one. And if I solve for x, or subtract all those things from 360, I see that that angle measure is 125 degrees. So I'm going to go ahead and fill that in. And now, since I know that this is a linear pair, I know that that interior measure is 55. Now it's asking what's the sum of the interior angles. Here there's two ways I can do it. I see that this is a 5-sided figure, so it's a pentagon. So I know I can do 180 times 5 minus 2, because I can make 3 triangles with the inside. Or I can also, since I know all the interior angles, I can literally just do the sum. So I can think 110 plus 120 plus 115 plus 140 plus 55. You can plug both of those in your calculator and you'll see that they both equal 540. Oops. Last one is what's the measure of each interior angle of the polygon? Well, I've actually already filled all of them in. And for this type of situation, since I've filled in my picture so well, I can just say on the picture, since they're already all labeled.